So in the last video, I talked about indefinite integrals, and I introduced this idea that we can find the value. It's actually the page I want to be on, is it? I want to be here. We can find the value of these indefinite or improper integrals by looking at using limits. And the example that I gave, we had a limit from 1 to infinity of something of a function, and we converted that to this other sort of this other integral, the limit of another integral. And you can see these are the three kinds of cases we're going to deal with. One is where the endpoint of the integral is not finite, so integral from a to infinity of f of x dx, and that's what we're going to do is just call that endpoint b, and say we're taking the limit from b to infinity of a to b, of the integral of a to b of f of x dx. The other case we could have is like a starting point. Our starting point is infinite, so this should actually be negative infinity right here. Right. So the integral from negative infinity to b, to some number b of f of x dx, we'll say, okay, well, we'll just replace this negative infinity with a, right? And we'll say, we'll look at for the limit as a approaches negative infinity of the integral of from a to b of f of x dx. And the other case, the third weirdest case, it doesn't turn out to be that weird, but it looks weird, is where you've got both of the endpoints are infinite. So you're going from negative infinity to infinity, and what you're going to do there is split it up. Split up the integral into two parts, and that's totally legit. You can do that. You're going to pick some point c in between, in between negative infinity and infinity, which gives you obviously a lot of options. You're going to look for some number where it's going to be easy to evaluate this integral. And so you usually like kind of figure out, okay, what's the antiderivative of f of x, and then figure out something where like, if some number that's going to make that antiderivative 0 or 1 or something easy to deal with. You can pick anything. And what we'll do is we'll do one integral with a lower limit, a lower infinite limit, like the limit from a to negative infinity of the integral of a to c of f of x dx, and then you'll split up and then you'll do the other one where you say, where you make it the upper limit infinite, and you take the limit as b goes to infinity of c, the integral from c to b of f of x dx. So you just kind of cut it down the middle, and then you go from negative infinity to 1. You basically make one like this lower limit, lower infinite limit integral, and you make the other one like this upper infinite limit integral. Again, convergent and divergent. Talked about this in the last video, but in the first two cases, the improper integral converges if and only if the limit exists. So if this comes out, if this exists, and remember from our very first unit in calculus, we talked about a limit. The limit exists if and only if it equals some finite number. So not infinity. That means the limit doesn't exist. 0 is fine. Infinity, no good. Right? Otherwise, it diverges. So if this doesn't come out to some finite number, then it diverges. In the third case, the improper integral converges only if both limits exist. So you have to have, like, this one has to work and this one has to work. Otherwise, it diverges. So let's look at some particular cases. All right, infinite lower limit. So I've got one that's an infinite upper limit, right? 0 to infinity. I've got one that's a infinite lower limit here, negative infinity to 0. And then I've got one that's got infinite upper and lower limits. This is going from negative infinity to infinity. And I'm going to do each of these three in turn so you get to see how it works. Okay, starting with number 1. So the integral from 0 to infinity of e to the x over 1 plus e to the x dx. So the first thing I'm going to do is rewrite this as a limit. So the limit as, I'm going to say as b goes to infinity, because then I'm going to replace that infinity up here with b. And you just replace it with some variable. I usually use b for the upper limit and a for the lower limit because it keeps it straight in my head. Of e to the x over 1 plus e to the x dx. Now if I want to do this integral, I'm going to do some straightforward u substitution. So I'll do, say, u equals 1 plus e to the x, which means du just equals e to the x dx. So that gives me, so, and my advice is to evaluate the indefinite integral. Don't worry about 0 and b and the limit and all that stuff. Just figure out what the indefinite integral is. So in fact, in a way, it might be better to think of it like this. Come on, eraser. Think of it like this. I've got the antiderivative, e to the x over 1 plus e to the x dx. I've done my substitution. That gives me du over u, or u to the negative 1 du, and that's going to give me ln u, which is, if I go back and substitute back in, 1 plus e to the x. All right, so that's that's how I've evaluated this antiderivative. So that means that I end up with, going back, oh, I see. The limit as b goes to infinity of ln 1 plus e to the x from 0 to b. Now, just do my regular way I would evaluate any definite integral. It's going to be the value at b minus the value of this function here at b minus the value of this function at 0. So I will say limit as b goes to infinity of ln 1 plus e to the b power minus ln 1 plus e to the 0 power. And then I can go from here, limit as b goes to infinity, and I kind of see where this is going to go. I think 1 plus e to the b minus ln 2. And, well, as b goes to infinity, e to the b is going to go to infinity. So 1 plus e to the b is going to go to infinity. So ln 1 plus e to the b is going to go to infinity. So this part here, I'll put it a different color, this part here is going to go to infinity. So this whole thing has no value. It all goes to infinity, so there is no limit, which means that this integral that we started with diverges. And that's not how you spell diverges, is it? Let's try this. Doesn't, not to say that it diverges. All right, so we could say I usually just write div, means it's divergent, nothing to say about it. Okay, that's sort of a disappointing first case. Let's look at this one. The limit from negative infinity to 0 of e to the 2x dx. So this one has an infinite lower limit. Do the same thing. Okay, so we'll say this is the limit as, and now I'm going to call this, like I said, I usually call the lower limit a and the upper limit b, so it's a approaches, what am I doing? Back. So, limit is a approaches negative infinity. The integral from a to 0 of e to the 2x dx. Okay, again, I'm gonna bracket this part, and I'm just gonna deal with this antiderivative first. So not worry about the limits of integration or anything, or the limit here. I'm just gonna figure out what this is, and then I'll go back and put it in. So I'll say u equals 2x. I'm gonna do substitution here. It's a good idea to do the substitution, because this is where a lot of people make mistakes. Okay. Where they forget the 1/2 or something like that. So you end up with 1/2 u, e to the u du, which is just 1/2 e to the u plus c. But we're not going to worry about the plus c because we're not going to actually use it as an indefinite indefinite integral. We're going to use that as a definite integral. So what we get is, we're interested in, go back to black here, limit as a goes to negative infinity of negative integral from negative infinity to, sorry, no. That's why I did that, right? From a to 0 of e to the 2x dx, and we say this equals the limit as a goes to negative infinity of 1/2 e to the 2x from negative infinity, sorry, a to 0. Now, we'll evaluate this just like we would any definite integral. This is going to be 1/2 e to the 2 times 0 minus 1/2 e to the 2 times a. So we're looking at the limit as a goes to negative infinity of, I'm going to pull the 1/2 out because it's just going to make things easier. 1/2 e to the 0 power, 2 times 0 is 0, minus e to the 2a. Now, what's going to happen is e goes to negative infinity. I'm going to end up with e over here. Well, this is just, right, this is just 1. So I've got 1/2 times 1 minus e to the negative 2 infinity, right here. This is what I'm going to end up with. So e to the negative infinity, that's the same as 1 over e to the infinity, or in this case, 1 over e to the 2 times infinity, which is really no different. So you can think of it kind of like I've got 1 times e to the 2 times infinity. And this whole thing, this is going to be 0. This term here is going to be 0, so I'm just left with 1/2 times 1 minus 0, which is obviously just 1/2. So I've got a finite limit. I know I've got a limit there, so I can say the limit converges, and it converges to 1/2. So this integral here has a value. It's 1/2. The integral from negative infinity to 0 of e to the 2x dx is equal to 1/2. If it has a solution, right, if there's an answer here, if there's a finite number here, that means it's convergent. There's no other way for it to be convergent. So this integral converges, and the solution is, the answer is 1/2. It equals 1/2. All right. Case where there's upper and lower limits. This is a little bit trickier, but it's actually not that bad. So I'm going to have to split this up, right? I said I would split it up into 2 integrals. And I said I was going to pick something, so I'm going to go from, negative infinity to some number here, to x e to the negative x squared dx. And I'm going to add that to whatever that number is to infinity to x e to the negative x squared dx. I want to pick something that's going to be relatively simple. In this case, I know I'm going to end up with some sort of e to some power, right? I mean, you can sort of figure out what it's going to be in a second. But if I've got e to some power, the easiest thing is probably just going to be to go from negative infinity to 0 and from 0 to infinity, because e to the 0 power is going to be 1. It'll be relatively easy to deal with. So I pick 0 as my term in between negative infinity and infinity, to split up this integral into 2 parts. Okay. So this side I got limit as c goes to infinity, or c goes to infinity, yeah, that's right, of, now wait, what am I thinking? Okay, sorry. Limit as a goes to negative infinity, right? Because I'm going from negative infinity to 0. The integral from a to 0 to x negative x squared dx plus the limit as b goes to infinity, positive infinity, right? Because this one, the upper limit is the infinite limit. Limit as b goes to infinity of the integral from 0 to b of 2x e to the negative x squared dx. All right, I can evaluate both of these. Make a 2x. I'm sorry, I left an e out here. 2x times e to the negative x squared. Make a long story short. Once I do that, what do I get? I end up with the antiderivative of 2x e to the negative x squared is e to the negative e to the negative x squared. So I end up with the limit as a goes to negative infinity of negative e to the negative x squared. If you don't believe me, you can work it out on your own. And you know, no reason to believe me. Obviously, I'm wrong about as often as I'm right. So, and the limit plus limit from b to infinity of same antiderivative, negative x to the negative e to the negative x squared from 0 to b. Okay, what do we get here? Hopefully something good. Yeah, this actually works out kind of pretty. Okay, so that's going to be the limit. A goes to negative infinity of, well, negative e to the 0 power minus negative e to the negative a squared power. And here, I'm going to end up with limit. You got to keep track of the negatives here. This is where it gets, I mean, this is just an integration thing in general. Well, not, it's just dealing with, yeah, I don't know. Dealing with infinity, it's always a little weird. Okay, from, oh, so I was going to actually, no, I know what I was going to do here. So let's call this negative e to the negative b squared minus negative e to the negative, or to the 0 power. So, I'm going to, this gets a little tedious, but I'll go through it's worth going through the details here. Negative 1 plus e to the negative a squared. Well, a is going to be going towards negative infinity. If I square that number, it's going to be positive, right? Negative times a negative is a positive. So I end up with a negative then, because it's negative a squared. So I end up with plus e to the negative infinity, so, or negative some increasingly large number, which is the same as 1 over e to the, you know, some infinite power. And obviously, as a goes to, right, oh, sorry, think of it this way. Right, this is going to go to 0. So this whole thing right here is it's just going to end up being negative 1. And on this side, something similar happens. I get limit, b goes to infinity. I've got b squared, that's the same as negative 1 over e to b squared power, plus 1, e to the 0 is 1. All right, so I've got here, this term is going to go to 0. As b goes to infinity, this term will go to 0, and so I'm left with just 1. And so I end up with negative 1 plus 1, which is hopefully 0. All right, so this one converges, and it converges to 0. I know sometimes that seems like a lot of work to go through just to get 0, but that's what it is. All right, that's the answer. So this is how we split it up. We picked a number c in between negative infinity and infinity that was going to be easy to evaluate, and we saw that it was easy to evaluate down here, right? Because I put in 0 and I've got e. Now, if I pick something else like 1, what would I get? I would have ended up with negative e to the first power plus positive e to the first power, right? Instead of 1, I would have ended up with e to the first. So I would have ended up with negative e plus e, which is also 0. It didn't make any difference. It's just you want to pick something that's easy to use.